Measuring and percentage uncertainty. When quoting a measurement, the actual uncertainty will depend on the instrument used. For example, a meter rule has divisions of 1 mm, so you can measure to plus or minus 1 mm. We say it has a precision of 1 mm. But there are two places to line up the object with the ruler, particularly if you're avoiding a damaged end. We need to line up the object here and take a reading, and here and take a reading. This gives an overall uncertainty of plus or minus 2 mm. With any measuring instrument, you can only measure to the precision of the smallest division. With a digital instrument, the last digit could be rounded up or rounded down. So, for example, if an ammeter gives a reading of 246 milliamps, it could be anything from 245.5 milliamps to 246.4 milliamps. So we must quote the reading as 246 plus or minus 0.5 milliamps. In general, the actual uncertainty of a measurement is of little value, as for example if a 4 meter room length is measured to an uncertainty of plus or minus 1 mm, this shows a high degree of precision, whereas measuring a 2 mm diameter rod to plus or minus 1 mm would be of little value. Percentage uncertainty is of far more value and is calculated as the actual uncertainty in our measurement divided by the quoted value for our measurement multiplied by 100 to get a percentage. For example, with the room given above, the percentage uncertainty is plus or minus 1 mm, or 1 times 10 to the minus 3 meters, the uncertainty in our measurement, divided by the length of the room at 4 meters, and multiplied by 100 to give a percent. This comes out at plus or minus 0.025%. Whereas for the rod, the percentage uncertainty is again plus or minus 1 mm, or 1 times 10 to the minus 3 meters, but now divided by 2 times 10 to the minus 3 meters, the diameter of the rod. Multiplying again by 100 gives plus or minus 50%. For a given measuring instrument, we can reduce the percentage uncertainty by maximising the magnitude of the measurement we're making. For example, with the rod, if we can line up several rods, like this, here there are 20 rods, so we'd now be measuring a length of around 40 mm to plus or minus 1 mm again. This gives a percentage uncertainty of the plus or minus 1 mm, now over 40 mm, multiplied by 100, just plus or minus 2.5%, a big improvement on the 50% we had previously. You would then of course divide your measurement by 20 to get the diameter of one rod. This method of measuring many objects together can mean a less precise instrument actually gives a smaller percentage uncertainty than a more precise instrument measuring one object. For example, if we want to find the thickness of one sheet of paper, we can use a micrometer which measures to within 1/100th of a millimeter. This is plus or minus 10 to the minus 5 of a meter. If the paper has a thickness of 0.1 millimeters, this gives a percentage uncertainty of 1 times 10 to the minus 5 meters over 0.1 times 10 to the minus 3 meters, the thickness of the paper, multiplied by 100. This is plus or minus 10%. However, if we measure the thickness of 500 sheets of paper using a ruler to within plus or minus 1 millimeter, we then get a percentage uncertainty of the millimeter over 50 millimeters multiplied by 100. This is just plus or minus 2%, 5 times better than with the more precise micrometer.